In this section, we're going to talk about complex numbers. Complex numbers arise when you have an equation like this, where if you solve for x, you end up with a negative that you have to take the square root of. Well, in the real number system, we don't know how to deal with that, but if we use imaginary numbers, that means we have x equals plus or minus the square root of 4 times negative 1, which you can pull that apart and you'll have plus or minus the square root of 4 times the square root of negative 1. Well, the complex number I is equal to the square root of negative 1. So taking the square root of 4 times the square root of negative 1, what that gives you is plus or minus 2 times I. So anytime you have a negative under the radical, that's called the imaginary unit I, which is equal to the square root of negative 1. Also note, and this will come up later, if you have I squared, that equals I times I, which is equal to the square root of negative 1 times the square root of negative 1. When you multiply a square root by itself, or basically you're squaring the square root, those undo each other or negate each other, and you're left with just what's under the radical. So what that gives you is I squared equals negative 1. So if you end up with an I squared term, you can substitute in negative 1 for I squared. So that's the imaginary unit I, which brings us to complex numbers, which are in standard form a plus bi, where a is your real number part and the bi is the imaginary number part. So you can write any number in the complex number form. If I have 3 plus 2i, 3 is my real part and 2i is my imaginary part, so that's already in complex form. If I have a real number, I can write that as 5 plus 0i, because there's no imaginary part, so that's in standard form. On the next one, if I had 6i, I can write that as 0 plus 6i to be in standard form. The next one, notice I've got a negative under the square root, so like we did above, if you separate that as 16 times negative 1, you've got the square root of 16 times the square root of negative 1. The square root of 16 is going to be 4, and the square root of negative 1 is where we put our I. And then in standard form, that would be 0 plus 4i. The next one, we have a real part and an imaginary part, so we'd have negative 5 minus the square root of negative 9 would be the square root of 9 is 3, and then the negative part gives you the I. So that in standard form would be negative 5 minus 3i. I wanted to add one more on here, just so you can see that you can also simplify an imaginary number. If I have negative 24, the square root of that, again, you can separate it as the square root of 24 times the square root of negative 1. So this part becomes your I. the square root of 24, 24 is not a perfect square, but you need to simplify it like we have in the past, where you do your factor tree, get your prime factorization. So, sorry. So my prime factorization is 2 times 2 times 2 times 3. So my twos, my pair of twos is a perfect square when it's under the square root, and 2 and 3 stay under. So the square root of 24 is going to simplify to 2 square root of 6. And then don't forget you've got the I. So what you have here is 2 square root of 6 times I. Now be careful. If you're entering that in that homework, the I is not under the square root. So what I like to do is put the I in front of the radical and enter it like that. But the 2 square root of 6 times I is also correct. What you don't want to do is leave the I under the radical. That is not correct. So that's a little intro into imaginary numbers. You can also do all your operations with imaginary or complex numbers. So addition and subtraction, you just add the real parts and add the imaginary parts. So here if I want to add 3 minus 4i plus 2 plus 5i, I can just drop my parentheses because it's addition. And then I'm going to add my real parts together, which will give me 5. And then I'm going to add my imaginary parts together, which will give me a positive 1i, or just positive 1. So when you add those two complex numbers, you get 5 plus I. Subtraction's the same, you just have to be a little more careful, because when you subtract, you need to make sure you distribute that negative inside the second set of parentheses. So that's going to change the sign of everything that you're subtracting. So that'll give me 2 plus 5i minus 3 plus 4i. And then again, you add your real parts together. So I've got a 2 minus 3, which will be negative 1. And then the imaginary parts will give me a plus 9i. Now when we move on to a multiplication, you use the same rules as you do with real numbers. Here if I say it says find the product of 4 times 2 plus 5i, I'm going to distribute the 4 into the parentheses. So that's going to give me 8 plus 20i. On the next example, we've got two complex numbers together. Just like with any binomial, you need to FOIL this to get the product. So we're going to have 4 times 2, which is your first. Outside will be 4 times negative 5, so negative 20i. Inside will give you positive 6i. And then last will give you a negative 15i squared, because you've got 3i times negative 5i, so you'll get the I squared. Now remember from before what I squared is equal to. I squared is equal to negative 1. So you have 8. We're going to go ahead and combine them like terms, which will give me a negative 14i. And then it'll be minus 15 times a negative 1. So you'll have 8 minus 14i. That negative 1 is going to change the sign to get positive 15. And then you can combine your real numbers. 8 plus 15 is 23 minus 14i. So anytime you end up with an I squared, it's going to end up changing the sign of that term because you're multiplying it by a negative 1. And then that'll turn it into a real part that you can combine with your first part. Okay, so that's multiplication. Division is the one that's slightly different, and it involves conjugates of the imaginary number. A conjugate is simply where you change the sign of the complex part. So if I have A plus BI, its conjugate is A minus BI. So it's just the opposite sign in the middle changes. So let's start before we actually divide something. We want to multiply 9 plus 2i by its complex conjugate. So if I have 9 plus 2i, its conjugate is 9 minus 2i. So I'm going to FOIL that. So 9 times 9 is 81. Outside would be negative 18i. Inside would be positive 18i. And last would be negative 4i squared. So when you multiply anything by its conjugate, what's always going to, or the complex number by its conjugate, your middle terms are going to cancel each other out. And then you'll get an I squared term that equals negative 1 that will change the end number to a real number. So it'll change the sign to 4. And then you can combine 81 plus 4 to 85 to make 85. So when you multiply by the complex conjugate, you're going to get back a real number. Here's one more. If you just have the imaginary part, negative 5i, its conjugate is still just the opposite sign of the imaginary part, which would be positive 5i. And then when you multiply that together, you get negative 25i squared. The I squared is going to change it to positive 25 because I squared equals negative 1. Now let's talk about division because it involves the conjugates. I have this in quotations for a reason. You don't actually divide complex numbers, but there's a rule that you never leave an I or an imaginary part in the denominator. So we just found that if I multiply a complex number by its conjugate, it goes to a real number. So you're going to use that to get rid of the imaginary numbers. So you're going to multiply top and bottom, so numerator and denominator, by the complex conjugate of the denominator. And that will get rid of the imaginary part in the bottom. So say, for instance, I've got evaluate the expression. So it doesn't necessarily say divide, but it's a division problem. It's a imaginary in the bottom, and it says write the result in standard form. So I've got negative 3 plus 4i over 2i. I'm going to take the complex conjugate of the bottom, which is going to be negative 2i, and multiply it by itself to get rid of the imaginary part. But whatever you do to the top, to the bottom, you also have to do to the top. I have to multiply top and bottom because then what I'm really multiplying by is equal to 1. So I'm not changing the value, I'm just getting rid of the imaginary part in the bottom. So on the top, make sure you're distributing this to both parts. So I'm going to have positive 6i minus 8i squared. And then on the bottom, I've got negative 4i squared. So that's going to give me 6i plus 8. When I change the I squared to negative 1, it'll change that sign. And then the same thing down on the bottom, the I squared will change that to a positive 4. So I've got 6i plus 8 divided by 4. That can be simplified a little further. The 4 is dividing both parts, so you can split that up and then reduce it. 6 over 4 will reduce to 3 over 2 with the I. And the I can go with the 3 on top. You can have 3i over 2 or 3 over 2 with the I out beside it. Those are equivalent. And then plus 8 divided by 4 is just 2. Now we're almost done, except we need to be in standard form. We need to switch that around, so it's 2 plus 3 over 2i. And that's your answer in standard form. So make sure you, after you've multiplied by the conjugate and gotten rid of the imaginary part, you put it in standard form with the real part first and the imaginary part second. Let's do one more. Again, this doesn't necessarily say division, but we've got a fraction with an imaginary part in the bottom. So we're going to multiply by the conjugate of the denominator, so 4 plus 2i. And we got to do that on top and bottom. So let's look at the bottom first, because this is what's always going to happen. When I FOIL that, I'm going to have 16 plus 8i minus 8i, and then negative 4i squared. So just FOILing that gives you the denominator. And then you also need to FOIL the top. So I'm going to have first will give me 2 times 4, which is 8. Outside will give me positive 4i. Inside will give me positive 12i. And last will give me positive 6i squared. So now you change all of your I squareds to negative 1s, which is going to change the signs, and combine like terms. So I've got 8. Well, let's go ahead and combine that with the negative 6 now. So I'm going to have 2 plus 16i. And then on the bottom, my middle two terms will cancel each other out, and it leaves me with 16 plus 4, which is 20. And then you can separate those. 2 over 20 plus 16i over 20 and reduce. So I've got 1 over 10. Oh, I made a mistake up here. This should be, no, I did make a mistake. We're good. That's 1 over 10 plus 4 will go into 16 and 20. So that'll be 4i over 5. So that will be your answer for that one. Or you can also, at this point, just reduce without separating it everything, all the terms, what will go into all of them is 2. So you can make that 1 plus 8i over 10 and leave it in that form. Either one is equivalent. So that is how you do division with a complex number. Make sure you never leave the I in the bottom, which means you have to multiply by the conjugate on the top and the bottom.